Okay, so in this video I'm going to have a look at the 2023 Higher Level Leaving Cert Maths Paper 1, Question 2. So we have f of x is equal to x squared plus bx plus c. B and c are real. F of x has a local minimum point at 3 minus 1. Find the value of b and c. Okay, so when we talk about local minimum, local maximum point, we really need to be thinking about differentiation here. So let's have a look. We have our function here, which is f of x is equal to x squared plus bx plus c. Now if we were to differentiate that, we would get 2x plus b. Now for a local maximum or local minimum, this here would need to be 0. So in other words, 2x plus b would need to be 0. But we know that our local minimum point here is at 3 minus 1. So we know that x is 3 at the local minimum. So at x is equal to 3, we know that we have 2 times 3 plus b is equal to 0. That'll give us 6 plus b is equal to 0, or just b is equal to minus 6. Okay, so we now have b as minus 6. So our function now is f of x is equal to x squared minus 6x plus c. We know that we have a point on this graph at 3 minus 1. So we know that when x is 3, y here, this is y, remember? So y will be minus 1 at x is equal to 3. So we can just put 3 in here, and that should give us c. So we've got minus 1 is equal to 9 minus 18 plus c. That'll give us minus 1 is equal to minus 9 plus c, or just c is equal to 8. So there are two answers. Our function then is f of x is equal to x squared minus 6x, x squared minus 6x plus 8. And I know that if I put 3 in here and here, I should get minus 1. You can check that if you like, but they're my two answers there. B is minus 6 and C is 8. Okay, let's have a look at part B then, the next part of the question. So this is a limits type question. So we have the limit of n over n plus 1 plus n plus 1000 over n plus 1 over 3 to the power of n. And we've got to find the value of our limit. So we have the limit of this term, and this term here. So really what we're going to do here is find the limit of each individual term. So really this is equal to the limit as n goes to infinity of n over n plus 1 plus the limit as n goes to infinity of n plus 1000 over n plus again the limit as n goes to infinity of 1 over 3 to the power of n. Now, I just raised 1 to the power of n, which is 1, and 3 to the power of n, which is 3 to the power of n. So let's do these individually. So the way you do these ones when n goes to infinity here is you divide above and below here by the highest power of n. The highest power of n is 1, so we're going to do the limit as n goes to infinity of n divided by n is 1, n divided by n is 1, and 1 divided by n is 1 over n. So all we've done is divided above and below here by the same thing. So we haven't changed the fraction. So we've divided the top and the bottom by n. So we're going to do the same here. The highest power of n here is also, the highest power of n is 1, so we're going to divide by n to the power of 1. So it's going to be 1 plus 1000 over n, all over n divided by n, which is 1. Over here, the limit of this function here is just going to be 0. Remember, 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3, 27, and so on. The denominator is getting bigger and bigger and bigger. So if this denominator here goes out to infinity, which will happen if n goes to infinity, the fraction itself will just tend towards 0. So the limit of 1 over 3 to the power of n is just 0. So really what we end up with here is 1 over 1 plus 0. This will just become 0 because n will go out to infinity. So the limit here is just going to be 1. The limit of this is also going to be 1, and out here is going to be 0, so our answer is just 2. And that's it for part B. The limit of that function there as n goes to infinity is 2. Okay, so let's have a look at part C then. We have a function. We're not told what the function is, but we have a graph of it here. And our domain goes from -2 to +2. X is real. Now, its graph is shown in each of two. Okay, so we have two diagrams here. Draw the graph of g of x minus 2. So what would happen if we took our function and subtracted 2 from all the y values? Well, what's going to happen is this entire graph here is going to move down 2 units. So let's do that. So I'll do that just in a slightly different color here. Let's see, we take this point here, move it down 2 places, so that's going to bring me here. Take this one, bring it down, it's going to end up here. Let's take this one out here, bring it down to here, 2 places. Take this one, is going to end up probably around there somewhere. This one here is going to end up probably here. This one probably here. So you're going to end up with a graph that looks something like this. Straight line down there, and then a curve around here like that. Okay, you might be able to do it a bit better than that yourselves. Let's try that again. Okay, and that's it. That's the entire graph moved down 2 units. Now the second graph here is we have to draw the graph of g of x plus 3, and the x plus 3 is in brackets here. What happens here is that the entire graph is going to move to the left 3 places. It's kind of counterintuitive. You would think it might move to the right 3 places, but it actually moves it to the left 3 places. So what we're going to do is take this point, go to the left 3 places, take this one to the left 1, 2, 3 places. This one here, 1, 2, 3. This one here, 1, 2, 3, probably somewhere around there. This one here, 1, 2, 3, probably around there somewhere. So let's connect those up then. So we're going to end up with a straight line here, and then a curve around here like this. And that's it. And in fact, that's it for question 2.